Tech by Tips.
Hello and welcome to another video of Tech by Tips. I'm Jorge, thank you for being here. And as you might have guessed from the title of the video, we're going to be talking about Raspberry Pis. Specifically, we're going to be talking about how to boot them from the network. You've probably seen other videos from other people on YouTube that tell you how you can set up a PXE server so you can boot your Raspberry Pis from them on the network. But it usually involves a lot of process. You have to go into the Raspberry Pi, you have to configure a lot of things, and for a lot of people that are not very technical or that might find it just a little bit daunting, they might be put off by it. But today we have good news. Today I'm going to share with you Bash application, a shell application that I have created for you to create a Raspberry Pi PXE server. And the good thing about it is that you can use any Raspberry Pi to be that Raspberry Pi PXE server. Could be a Raspberry Pi 1B, for example, that I have here, all the way up to like a Raspberry Pi 4. It doesn't matter, it works with all of them. Why would we do this, right? That'll be the question, like, why would I go through the effort of creating a network booting setup, right? Well, if you're like me, you might have several Raspberry Pis that you use for different things. And as you know, it is pretty cumbersome sometimes to have to deal with the SD cards. Many things can go wrong with the SD card. The SD cards can just die on you, or in other cases, if you're working on a Raspberry Pi, for example, let's say you're creating a script and you put it in the etc profile D folder so that it starts up with the Raspberry Pi, but something is wrong with the script and then you cannot log into the Raspberry Pi again. You have to flash your SD card again, or maybe put it in Windows and use a special program to access the Linux file system to remove that. You know, there a lot of things could go wrong, right? And you lose access to that Raspberry Pi OS file system. In this case, we have the ability to change anything in that file system from our network. You know, undo that problem that caused us to not be able to log into the Pi, or you know, if your SD card dies, you don't lose what you had in your SD card because it's safely stored in the network. So that's what we're going to be focusing on today. We're going to be using Raspberry Pi 1B as a target machine that is going to boot from the network, and we're going to have another Raspberry Pi 1B that is going to become our Raspberry Pi PXE server that is going to be able to provide any other Raspberry Pi in our network with the boot files that they need and their file system outside of an SD card, which is great. So let's go and have fun. In case you're trying to figure out what happens when you're trying to boot a Raspberry Pi from the network, here's a small simulation of what goes on. Your new Raspberry Pi screams out to the network, "Hello everybody, I'm a new guy here. My serial number is ADC78SD. Can anybody tell me which IP address I can use?" Then the router catches that and says, "Hey new guy, welcome. You can use this IP address, 10.0.0.160. And then the Raspberry Pi screams again to the network, "Hey, I don't have an operating system. Can you tell me how I get one?" And then the router in our case says, "No clue, my brother, good luck." But fortunately, we have the Raspberry Pi PXE server listening on the network, and it goes like, "Hey new guy, I happen to know a guy who can get you the stuff you need. Go talk to the old man named NAS. He'll get you hooked up." And then the Raspberry Pi reaches out to the NAS. "Hey Mr. NAS, could you provide me the operating system files for serial number ADC78SD? And the NAS replies, "Sure kiddo, here you go," and gives him the files. And now our Raspberry Pi is successfully provisioned over the network. Alright, to install the Raspberry Pi PXE server, we have our target Raspberry Pi PXE server here on the left, and also here down here on the right. And on the top right, we have another Raspberry Pi that we're going to use as a target to image and provision, right? Currently, it has an SD card with the system already running, and that's what we're seeing here. And additionally, I have already provisioned a NAS server with an NFS and Samba share. So So this is our share in the NAS. This is the PXE folder. It's being shared both through Samba and NFS. So now we're going to install the Raspberry Pi PXE server on our target Raspberry Pi PXE server. This is the server, or the Raspberry Pi, that is going to act as a server for all of the networked Pis in our network. So any Raspberry Pi that wants to boot from the network will submit a request in the network with the DHCP server, and this Raspberry Pi server is going to catch that request, and it's going to let that Raspberry Pi know where the files are to boot. So first, let's go option number 1, install the Raspberry Pi PXE server. It needs to update the list of packages in our Raspbian operating system. After that is done, then we start upgrading the packages to make sure we have the latest version of every package. Right after that, we also make sure to upgrade the system to make sure we have the latest version of the operating system files. And then we proceed with the installation of the required packages for the Raspberry Pi PXE server to work. The first one that we need to install is the NFS kernel server, because we're going to need to serve some files using NFS from this Raspberry Pi. We need to let other Raspberry Pis know here's the files that you need to boot. So that's why we need this. Additionally, we're installing Samba to be able to mount that share into our Raspberry Pi PXE server. It helps us with copying some files, and we also need to know that we cannot re-export an NFS share, so that's why we need to mount the file system from our NAS with Samba. Then we can re-export it with NFS. Next thing we're going to do is install CIFS utils. Since we're going to be using Samba, it also helps with handling Windows formatted structures, right? So we can mount the Samba share as a CIFS, so that's something useful to have. Additionally, we need to install the DNS mask service, because this is going to act as our DHCP service, right? Even though we were not going to assign IPs or give out leases from this Raspberry Pi, we need to listen for those DHCP requests, because that's when we know that a Raspberry Pi is asking for its boot files to boot from the network. So we will configure DNS mask in a way that it doesn't give out leases, but it's listening for the DHCP requests and then replies with the location of the files that the Raspberry Pi needs to boot from. Additionally, we need to remove any unused packages here, so we don't have any bloatware in the Raspberry Pi. So that's just a little bit of housekeeping, and that first part is done. Now we press enter to continue, and then we're given a description of what we can do with the Raspberry Pi PXE server. We can run it with 3 different ways, right? Number 1 is using a NAS server to store and serve the files, which is what we're going to do now. Option number 2 is actually mounting a hard drive on the Raspberry Pi and then using that to hold our files that we're going to be serving. Or option number 3 is actually using our boot device, which could be the SD card, or if you're booting from a hard disk, then it'll be using that hard disk to hold those files. It's important to know that, ideally you don't want to use an SD card, because number 1, it would have to be a very big SD card to hold all the file systems in there, and additionally you're going to be writing and reading a lot from that, so its lifespan will probably be very short. So that's why it's not really recommended to do that. So let's go with option number 1, which is using a NAS. And then we're given a brief description of what the file structure that we were going to be creating for the Raspberry Pi PXE server is going to be. So basically we have the root of our SD card, we mount the NAS share into the PXE folder. We're going to mount it both ways with Samba and NFS. There's a reason for that. The NFS one is important because when we copy the file system, we want to preserve permissions, and Samba does not do that. It messes up the permissions. So that's why we have that mounted also. But the boot files, they don't really matter. The permissions are not important, so we can mount that with Samba. And then we can actually export it again and serve it from our Raspberry Pi PXE server. And then inside that, we have a boot folder that contains the boot files for each Raspberry Pi. The file systems folder contains all the Linux file system for each Raspberry Pi, and then we have the images where we store the images that we create of our Raspberry Pis to provision other Raspberry Pis after, right? Yeah, basically that's it for this part. We just press enter to continue. That was just an explanation of what I just said. So we press enter, and then it created the basic file structure. So we can validate that in here by doing this. Now we have the NFS PXE and PXE folders, which are currently not mounted to anything, and they just have a basic structure that we need to then mount the folders. Then it asks for the NAS IP address, so we're going to give it that. Then the NFS mount path that we created in the NAS. Then the Samba share, the username to mount the Samba share, and the password. Now it is actually doing the mounting and establishing our file system. We can go back into the NAS, and we now see that we have files in here. And the boot folder contains the boot code bin that we would need to put inside an SD card for like a Pi 1B or Pi 2 or Pi 3 for them to boot from the network. Now, if we go into here, there's nothing here in the file systems. There's nothing here in the boot folder. There's nothing here in the images, boot, and images file system yet. So it's brand new, clean, has nothing there. But at least the structure is there, and it means that it was successful in mounting it here. So we can validate again. We can see that the Samba share is mounted and the NFS share is actually mounted. So we're good on that side. Now we press enter to continue. And now we are basically configuring DNS mask and other network configuration files to make sure that the system is ready, up and running, and we're enabling all the system services that are required for the Raspberry Pi PXE server to work. And we're finally done with the installation. Everything is ready. Now we just need to press enter for the Raspberry Pi to restart and start up fresh. We can easily check information about our Raspberry Pi PXE server here too. If we select option number 3, it's going to give us information about our current Raspberry Pi running the Raspberry Pi PXE server. There we go. So now we have the information here of our Raspberry Pi PXE server. We can see that it's running Bullseye. We can see the name, the host name for it. We can see like serial number, MAC address, and network information. And this host name we can change also if needed. So we can press enter, go change host name of this Pi, which is option number 4, and then we can rename it something else like Raspberry Pi PXE. Now when we go and check the details of this Pi, now it says Raspberry Pi PXE. Okay, we are back and our Raspberry Pi PXE server is up and running, and we have validated that upon booting it mounted successfully the shares, and we currently don't have anything being exported through NFS, so everything is looking good here. If we go into here, we still have nothing in our images and nothing in our provisioned Pi folders, so we're clean there. And let's go ahead and identify Raspberry Pis in our network so that we can figure out Raspberry Pi to provision, right? So we can go into the option number 5 here, which is identify Pis in the network. This will basically do a ping for all of our networks so that we can populate our ARP table, and then it'll filter out those devices which are Raspberry Pis and give us a list of the Raspberry Pis that we currently have in a network, so we can image one of them, right? So here we have several Raspberry Pis. I'm going to use this one, the 160, which is this one that we have here for our target. So we know it's 10.0.0.160. So now that we know that, we can also see details about that Raspberry Pi. So we can go and option number 6. We can get details about 10.0.0.160. We provide the Pi username to SSH into it and our password. And we'll get some basic info about that Raspberry Pi so we can make sure that we have the actual Raspberry Pi that we want to image. So yeah, it is the raw Pi, which is this one. So yep, it's a Raspberry Pi Model B, so it's one of the old ones, but it is still capable of booting from the network if we do it right. So yep, now we know that. We can go ahead and provision that Pi. So we go into make an image of a Pi. Option number 7 will create an image of this Raspberry Pi that is currently running. So we're going to copy everything from that SD card into our images. We need to provide the IP of the Raspberry Pi that we're going to image, 10.0.0.160. And then we have to give this image that we're going to create a name. So what we're going to do is we're going to give it a name that is actually meaningful to us. Like, we know it's a Pi 1B, so Pi 1B, and we know it's running Bullseye, and this is just a clean install. So we're going to name it that, Pi 1B Bullseye clean install. So now we know whenever we want to provision something that is Bullseye and has nothing installed, we can use this image. So we press enter, and then it tells us that in order for us to make an image of this Raspberry Pi, we need to log in as root through SSH, because we're going to have to copy everything in its file system, and root is the only user that has that full access. It gives us the details of how we can do that. If we have not done so already, it's by default, it's not enabled. You cannot log in as root, so we have to enable it. Here are the instructions, and there's a big note at the end that says that it is recommended that you undo these changes after we're done. For security reasons, allowing root SSH access is actually very highly discouraged. So those are the steps, and then go in reverse and undo it. Now we provide the root password. I've already set up a root password for this Raspberry Pi. And then we'll see in this Pi that the Raspberry Pi-PXE server is connecting to it, and it is doing things. You see, making sure NFS common is installed, apt-get install. So it is doing remote commands from this Raspberry Pi-PXE server into this Raspberry Pi that we're going to copy as an image. Now we're copying the boot files from the boot partition into our boot image. So now you can see that we have one folder that is being populated with files. And then now we're down to copying the actual file system. So if we go back into images and file systems, we're populating the file system of this Raspberry Pi, Pi 1B Bullseye clean install. So everything is being copied. This is a process that takes a long time. So we're just gonna give it its time to do its thing, and we'll be back when that's completed. I don't want you to be here for an hour watching paint dry. Oh, I forgot to mention that to copy the file system, that's why we need the NFS share. So that's why we're using rsync, because it preserves the file permissions of all the files that are in the file system. Okay, we're almost there, down to the last bit of the file system copy. Okay, we're down to the very end, it copied everything from the file system. So now we have successfully created an image of a Raspberry Pi here, and that basically took about almost 30 minutes to copy everything with the permissions and in order. Let me see how big that file system was. I think it's like about 1.5 gigs or something like that. Yep, looks about right. Like, or even more. Okay, that was no wonder it took about 30 minutes. It's a pretty big file system that was copied here. So now we are ready to start provisioning Raspberry Pis using this image that we have created of a Pi 1B running Bullseye. Now that we have an image in our RPi-PXE server, we can use this image to deploy a Raspberry Pi in our network. Currently our folder is empty, we have not deployed any image, so let's go ahead and deploy a Raspberry Pi image. Here's the name, Bullseye Clean Install. So we go into the RPi-PXE server and we select the option provision a new Pi using an image, which is option number 8. It'll tell us to provide the image name that we want to deploy. So we go Pi 1B Bullseye Clean Install. So now we provide a serial number of a Raspberry Pi to provision. Here we have our target serial number, and it'll start creating here a folder with that Raspberry Pi serial number. First thing it does, it copies the boot files, and then it goes into file systems and creates that same thing. First we'll see that it has the name of the image, but once it's done copying all the files, and it'll rename it to the serial number of the Raspberry Pi that it's going to boot off of that. This is going to take a long time, so we're going to pause until that is complete. We'll be back in a bit. Okay, we're back and it has finished copying everything. As we can see, the image has been renamed with the serial number of the Raspberry Pi in the boot and in the file system section, so that is looking good. Now it says please provide the IP of the NFS server, so we're going to provide this. And then we're going to provide the NFS mount point chair of the chair. And it basically goes ahead and makes some changes in the configuration file of that Raspberry Pi. That's in the boot section. We look at the command line, then we see that now it should boot from the NFS share that we have. It also makes changes to the etc fstab, so if we go into that, we'll see that that was also modified. So now we have mounted that as the location of our boot and file system also, and other things were done in the background to make sure that it is served properly. So if we check the exports in our PXE server, we should see that now it is exporting the configuration for that Raspberry Pi here. So now that Pi should be able to boot, the one with this serial number should be able to boot from the network without any problems. Alright, so now we're going to boot our Raspberry Pi from the network. This is currently the Raspberry Pi that we used to make an image. So let's first disconnect this Raspberry Pi. let's make sure we take out the SD card that has the actual operating system in it, and we're gonna substitute that card with a very small SD card that only has the bootcode.bin file in it. This is formatted as FAT32, so that's the only thing you need to boot for the network. Actually, you can even use a tiny SD card, because that file is very small. It could be like a 256 128 meg SD card, and it'll work. So I'm putting this one now. Once we plug it in, the Raspberry Pi will connect to our network and submit a DHCP request for a DHCP address, and that's what triggers the whole process for this Raspberry Pi to be provisioned. When it submits a DHCP request, our Raspberry Pi-PXE server is going to be listening in the network, and it's going to catch that request. So our router here just assigned an IP address to the server, but if you see VFS mounted root NFS full file system, that means that our Raspberry Pi-PXE server was able to catch that request and tell the Raspberry Pi, okay, I have a file system for you in the network, here's the location, boot from it. So the Raspberry Pi grabs the boot files from the network share and starts booting the system. And it also looks for the file system structure that is also stored on the network, and it boots the operating system from that network. So as we can see, the Raspberry Pi is actually successfully booting from the network entirely. And our Raspberry Pi-PXE server is serving as a mediator in our network to tell Raspberry Pis where to look for their operating systems. And just like that, our Raspberry Pi is working from the network. Let's log in to validate. And if we check here, we'll see that our structure is all coming from the network. So if we zoom in here, we'll see that our boot directory is coming from the NFS share in our Raspberry Pi-PXE server, and our file system that loads the operating system also comes from the NFS share. We currently have 2 Raspberry Pis provisioned in our Raspberry Pi-PXE server, but we want to remove one for some reason, right? So we have an option to do that. We can go back here and select option 10, which is delete a provisioned Pi from the server. And it prompts us for the serial number that we want to remove. We just add that, and then it starts deleting that Pi from our structure here. So we have 2 here. Let's go into boot. We only have 1, it already deleted it. Let's go in file systems, it's still working on it. So let's wait for it to do its deletion. This might take a little bit of time, so we have to be patient. Okay, it has completed the deletion and the folder is gone. So there's another thing that happened in the background, which is it removed the export. So if we look here, we no longer have that additional Raspberry Pi being exported, so that also got cleaned up. We can easily remove images that we have created by selecting option number 9, which is delete an image of a Pi. It'll provide us the name of that image, so we will give it Pi1b bullseye clean install. And then it'll go ahead and start removing that image from our images folder. So This is always kind of slow because it's the biggest folder. But yeah, it's deleting everything, cleaning it up, so we no longer will have this image available in our Raspberry Pi-PXE server. Let's come back in a bit when it's done processing. Alright, so it has finished deleting everything. As you can see, we do not have any images left in our images folder, so we are good. That's done, cleaned up. If we no longer need to use this Raspberry Pi-PXE server and we just want to get back to having a regular Raspberry Pi to use for something else, we can easily go with option number 2, which is uninstall the Raspberry Pi-PXE server. This will basically start by disabling all the system services. Next, we're going to be prompted if we want to delete all the folders and files that we have put in our structure. In our case, we were using a NAS, so it will delete everything from the NAS. We say yes, and we can see how things are going to start disappearing from here as it deletes the images and everything. Yeah, it has stuff to delete there, so that's going to take a little bit of time. Let's give it some time to process the information and we'll be back. And as we can see, everything has been deleted from here. The Samba mount and the NFS mounts have also been removed, so we can validate that by looking at our fstab file. Currently it doesn't have anything mounted, and it clearly says that it was deleted from the etc fstab, so that's why we couldn't see it. Now we're uninstalling all the packages that were installed as part of the installation of the Raspberry Pi-PXE server. Meanwhile, we can validate that there's also nothing in the exports. Alright, it took a little bit of time, but it actually removed the exports file, so there's nothing being exported with NFS, and we're removing Samba currently. Now we are also removing DNS mask as it's no longer needed. We also make sure that no other packages are left behind, so we clear any other packages that are not being used. And just like that, we are done. We're back to a clean Raspberry Pi. We can validate things like, for example, in a root, we no longer have the PXE folder. We have nothing mounted. Yeah, if I put cat, there we go. Nothing mounted and nothing exported in NFS. Nothing there. So yeah, back to a clean Raspberry Pi.